For our keynote this morning, we have Luca Rossi, founder of Refactoring, with his keynote on AI and engineering, closing the gap between expectation and reality. Welcome to the stage, Luca.
Right, mate. Thank you. Pointer is this one, right? Okay. Okay, hi everyone. So I'm so happy to be here. I want to thank Lee John and all the people at CTO Craft. I'm so excited to be opening this conference. So my name is Luca, and I'm a former startup CTO for many, many years. But today I'm just a newsletter writer. I write articles on my newsletter, I host a podcast, and these things go out weekly to many, many friends, software engineers and managers. And I largely care about two things: how we write good software and how we can work together. And so for today, I decided to bring kind of an unconventional topic. It's a little bit niche. I hope you'll be able to follow, which is AI. So has any of you heard about AI? Raise your hands. Has anybody reached out to you to talk about AI? Bring more AI in your lives? Yes, I'm one of those today. And so jokes aside, everybody's talking about AI, right? And so you may wonder, why should I talk about AI? So if you look at my bio, I'm no AI researcher, no machine learning engineer. I didn't get any 100 million joining bonus from big tech mogul. I wouldn't be here otherwise, honestly. But I do a weird job, which is to write a newsletter. But it gives me a perk. That is, I'm able to talk with a lot of people. And in many different ways, and I'm so grateful for it. So from the newsletter, we run surveys and polls. We are running an industry report on this topic, which is going out in about 1 month. And then we have a private community where we do many things together, and we talk about our own challenges, we help each other, we run weekly events, masterminds with Joel and Melinda, who are here. And then, of course, I also have a lot of one-on-one conversations, obviously with podcast guests, but also with fellow founders, other tech leaders, authors, and so on. And so we get from the more, the broad quantitative data points, which are a little bit shallow, however, to the deeper qualitative stories by individuals, which might be a little bit more anecdotal, right? But I think we really need both to understand where we are today and what's going on. And that's what I'll try to do today. So where we are today, I try to collect some stories and insights from both research and single people, which I found the most interesting, and bring them to you today to begin with. The first item is from our own research. We have run this survey to more than 100,000 engineers, and 27% of them say they're saving 10 hours plus per week by using AI. And actually, it's not in the slide, but it becomes 54% that is saving 5+ hours a week, which is already very good. And then a few months ago, I spoke with Salvatore Sanfilippo, also known as Anti-Res, the creator of Redis. And he writes, he's one of the most successful open source authors ever, and he writes some very complex, low-level system code in C, like he implements vector sets from scratch. And he says that he's at least 5 times faster at writing code with AI. And I also spoke with Dan Schipper, who runs Every, which is both a media company and a small software studio. And they make software as a service, and for tens of thousands of paying customers, they make more than 1 million ARR. And he walked me through how they work, and 90% of their code is just written by AI. They have full-stack engineers steering the output, but it's largely, we can say, vibe coding, okay? But then we have also stories that are a little bit less enthusiastic, okay? I spoke with Abe Noda, CEO of DX, and he works in engineering intelligence and works with thousands of teams and code bases, and he says that top performers are getting at most 10% in productivity gains from AI, which is very different from 5x, right? And then we get to the bad news, because late last year, in the latest State of DevOps from DORA, they found that more AI usage correlated with worse delivery performance, which is not good, okay? And also, the final nail in the coffin is this almost viral report by Matter, who found that many developers thought they were being faster by using AI, while instead they were being up to 20% slower than their peers who were not using AI, which it's kind of depressing. So the question you may have is just why? I mean, why is there such a difference between all this data, all these variance and diversity? And the question I want to ask you in return, because I only answer with more questions, is should this really be surprising? Because if you think about it, if you look at everything we know about software engineering performance and previous research, we've always had a lot of diversity and a lot of variance between different teams. So if we look back at, I don't know, Accelerate, which is probably the prime example of research about software delivery performance, it's from about 10 years ago, way before AI. And Accelerate already found that the gap between top performers and medium performers, so not like the bottom quartile, but like the average teams, on many measures, is like 20x, 50x, 100x in some cases. So the truth is, as an industry, my feeling is that we have never found a lot of consensus on many things. Everything feels controversial all the time. Testing is controversial. Documentation is controversial. Agile is controversial. And so I think it's just to be expected that AI is controversial, and there are teams that are getting more out of it than others. And it doesn't mean someone is right or wrong. All these stories can be right in their own way. And so it also means that if we just look at the averages, we are probably not getting a lot of information and signal out of this because there is too much diversity and variance. And so what I try to do is to speak with many engineering teams who are doing things in different ways and trying to connect the dots and find items and ideas that I think that can be useful for the rest of us. And so today I want to talk about 3 things. These things are, first and foremost, mental models, because I think it's important that we decide and get how AI fits into our mental space, into our team processes the right way. But there are also things that sometimes we are not getting right. We are getting kind of backwards. And I think it's very important. So the first one is that what's good for humans is good for AI. How many times we ask ourselves, how can I make this better for AI? How can I optimize the code base, the documentation, this and that, to make AI perform better? Actually, it turns out, when you look at how the best teams are using this, it's simply that when you make things good for humans, AI performs better in return, which is fantastic news, which we should not take in as a given. The second one is that we can use AI to improve code quality. And I say this intentionally because the main narrative around AI these days is that it's going to make code quality worse. We are making more code, less under our control, but it's actually in many cases the other way around. And finally, that we need to move beyond coding. We only talk about coding, but actually the job of an engineer is about many other things. And if we only speak about that, chances are our productivity gains really cannot go beyond 10%. So let's start with the first one. And I want to stress this because if you think about blog posts you may have seen or social media posts about stories of either teams or individual developers that got amazing results with Cloud Code or Cursor, and you read what they've done, a lot of the advice looks like this. Work in small batches. And I mean, I feel stupid that I need to elaborate on that, but I'll do it anyway. I mean, set clear goals. Man, you wouldn't believe it. Scope the things right. Commit frequently. That's the secret sauce, right? And things we have known for like 40 years. But still, here we are. The second item is create constraints, which is still probably not surprising, but maybe a little bit more interesting. That is, what we mean is AI performs better when it can physically make fewer mistakes because of how we set up the environment and the workflows, which is, anyway, just the same as our biological carbon-based friends. Which makes me think about this awesome quote by Charity Majors, who said, "Make the right thing to do the easiest thing to do." And so what does it mean? Of course, your mileage may vary on this, depends on your tech, on your product, but we can make a long list of things that help with this, like use static type languages, adopt strong linting, make your abstractions consistent across the code base so that AI doesn't get confused. And of course, good testing coverage so that we can spot errors. So the whole game is, on one hand, trying to prevent errors to happen at all from the start, and on the other hand, intercepting them as fast as possible, as soon as possible when they happen. Not surprising again. Third item, designing good context. And there's a lot of talk about this, which often goes by the name of context engineering, right? So how to give AI all the information it needs to do the things they need to do. And out of these three factors, this is probably the only one where AI is legitimately a little bit different than humans, but maybe for now. Because for the sake of simplicity, let's say that when we have to do something, there are two types of context that we need to deal with. The first one, I call it the broad context, where we have a lot of sources from these scattered tools, and we have to put them together, like the Slack chats, the tickets, the docs, wherever they are, if they are anywhere, OKRs, values, and so on. It's about small things, but in several places. And then there is the deep context. There are these few deep, big data sources that we have to get insights from, like the code base, for example, but also logs. And here's the thing. I feel that humans are amazing at broad context. We are able to fit so many things in our heads and negotiate with the constraints and find good solutions. While AI is, I don't know, it feels like it's better at deep context. Making sense of a large code base, it can do that. But if it has to fetch information from many different places, it becomes very easily confused. And this might be another limitation of the model themselves, might be a limitation of the tooling, because MCPs are still clunky, RAG feels like early tech. But it is what it is, and we play with what we have. So what do we make out of this? The consequence to make AI performs better because of this is to maximize the opportunity for local reasoning. That is, keeping things all in the same place when need to be accessed together. Which, again, I believe leads to good design decisions that benefit everyone, not just AI. Because local reasoning means low coupling, means more componentization, means, I don't know, documentation in the repo, all things that we have always known to be good for humans as well. So all the advice I've shared so far, I mean, I lured you in by saying I will be talking about AI, but it's like I'm just lecturing you about what good engineering looks like. Because a lot of this looks like the classic engineering trade-off. That is, whether to do more work in advance, good work that sometimes looks like grunt work, might be, right? To get some benefit later that we can summarize in higher velocity, right? But here's the thing today, is that with AI, it's like this scale is being tipped on both sides. Because on one hand, AI is helping a lot with the left-hand side of this. Because AI is fantastic at many of this. It's fantastic at writing tests, writing docs, all this stuff that feels boring for humans. We need to remember syntax, DSLs, etc. AI helps a lot with that. But it's also making the right-hand side heavier and more important, because now it's not just about our own human productivity. It's always about making AI do better work. And so it's like the ROI of good engineering is skyrocketing all of a sudden, because it's making things easier to do, the good things and the right things easier to do on one hand, and more valuable on the other hand. So the second thing I want to cover after what's good for humans is good for AI is code quality. And you might wonder, we don't need to talk about this separately, because good engineering already leads to quality. But I think we should instead, because this is literally the #1 concern by everyone we interview. So we've run this survey, and like 70% of software engineers are concerned that code quality is going down with AI. But here's what I believe about that we always talk about code generation, which has its own set of problems, but actually AI is very good at code reasoning. Arguably, it's better at code reasoning than it is at code generation. And I think that's because of the deep context idea that we discussed before. When AI has a code base in front of it, and it has to reason only on that, it doesn't have to fetch many things in different places. It can do a better job than creating things from scratch. And so it's already like that if you plug in many AI reasoning tools, they can pick up code smells, security vulnerabilities, tests, but also things you wouldn't expect genuinely, like things that are specific to your team, like whether you're adhering to your own conventions, best practices, and so on. And also, it is doing that so fast and so cheap that it's contributing to making the journey of code quality shifting more and more to the left, which is something that has happened all the time historically. Like, we started maybe, I don't know, 10 to 15 years ago. You remember those dashboards to run these checks like once a month? How is the coverage and stuff like that? And of course, this stuff went into the CI/CD and to the pull requests. But now it's more often IDEs plugin that can give you real-time feedback on the code that you're writing, if it has any smells or security issues and so on, which is arguably better because the code is not done yet. It's been written in that moment. And the next frontier might be, and there are already examples, MCP servers, like from Codacy, CodeScene, and many others, that are steering the code that is being written by AI, following good practices before it even hits the IDE. So I argue you can't go more to the left. I mean, this slide cannot be updated in any other way after this. But the thing is, we have to be intentional about this because it doesn't come out of the box. We need to embed these basic quality checks into our workflow so we free up people time and valuable human review time for the high quality and high value things. And then the final item is, I call it unblock engineers. But the thing is, we are always talking about AI for coding. But the elephant in the room is that engineers spend very little time coding. It's on average less than 1 hour a day. And if you're lucky to be in that 90th percentile, it's 2 hours a day, okay? It's 25% of your time. And so if you think about the gains in productivity you can get from AI coding, there is a very low ceiling to that if you're spending just 1 hour coding anyway. And you might wonder, where does the rest of the time go? Well, the rest of the time goes basically into coordination, working with other people, waiting for others to do stuff, to do their own thing, meetings that sometimes maybe are not necessary, but in general, managing coordination and communication, so tickets, statutes, process, which is all needed when you work with others, right? And so I don't think I will say anything controversial if I say that probably a recipe to do better is to try to spend more time building and less time coordinating, right? And this is not advice about AI. This works for normal teams. And how do we reduce the cost of coordination? Well, the cost of coordination grows with the number of people who are involved to ship things, to do things. And here I'm not saying we should lay off people or reduce the headcount. I mean the unit of work, the number of people who are in the loop for doing things, for ship anything. The fewer, the less the coordination. But the problem is, to reduce the number of people who are in the loop to do a full stack change on our product, we need to increase the scope of what individuals do, not just make them more productive at what they do. Because if we only do more of the same, we'll keep the same amount of people who do the things, and we keep the cost of coordination the same. But there is a reason why there are many people involved to do anything, or at least it feels like that, which is, over time, We wanted to make things easier, but we have probably made them more complicated. Let's admit it. Over the past 10 to 15 years, technology stacks have become more complicated. And you can see that because of the level of specialization that engineers have today, which is simply higher than there was 20 years, 15 years ago. So we have more slices, more layering, and so the level of scope that each engineer has is smaller than it used to be. And I think we can strive to make things easier. We can strive to make things in a way that the cognitive load for individuals is such that they can do more things. And again, this is true in any case, but with AI we have an additional incentive that you can use it as this kind of layer of universal basic proficiency. Gives you permission to go after things that maybe you wouldn't have tried by yourself. So what do I mean? I mean that if you're, I don't know, a senior front-end engineer, and you're using AI just to write more front-end code, chances are your opportunity of getting more productive are kind of limited, right? You're already an expert. I mean, how much you can get out of that? But let's say you use AI to go after that 20% of back-end code that is needed to ship that feature, other than your own front-end work. And maybe, I don't know, you have a shot at the design because your team maintains a good design system. So you can make a first try, and you don't have to keep a designer in the loop all the time. You spin up a preview environment. Maybe you even ship the code in a disabled state through a feature flag. So you have saved like 2 to 3 meetings, other people's time. Your code will get reviewed, but nobody ever gets blocked. Now we are onto something. Now we are talking, and it's not plus 10% anymore. The opportunity is much more. So how do we do that? How do we unblock engineers? Again, it depends here. There are no hard and fast recipes that work for everybody, and you should think for yourself. This is a mental model first, and not a directive advice to do this or that. But there are many ideas. I mean, they're all about keeping things easy. Keep technology easy. Keep the surface of your tech stack small so that it's easier to understand, which might be useful stack frameworks. Make boring choices using technology that everybody understands, that AI also understands. Keep deployments and CI/CD simple. I don't speak German, so I don't really know what's happening there. Yeah. Okay. Okay, I hope it was nothing embarrassing. Keep design easy, like maintain good design systems. So engineers can go after small things without having designers involved all the time. Make product easy. Define what success looks like so that people can iterate and improve things without being micromanaged by PMs. And remove the blocking parts of your processes as much as possible. Remove the parts where people have to wait for others to approve and do stuff. I don't know, decouple deploy from release, use feature flags, do asynchronous QA. You get it. So we covered a lot of ground. And I want to close with a reflection. That is, I think it's very important that we decide what our posture is towards AI and everything that's happening today. And there are many people who are legitimately anxious, scared, or even downright angry at what's happening, and they feel something has been taken away from them. Now, I'm here to say, it's a little bit provocative maybe, but that we have to be grateful. Because look at everything we have discussed today. Good testing, good design, work in small batches, increase ownership. It's like the greatest hits of the best engineering advice that we were ever able to create as humans. So how lucky we are that we stumbled on a technology that thrives on the very same things that we thrive on as humans. It was not necessarily true. And so today, if you are somebody who cares about good software engineering, you should be super excited. This is your time to shine. Because the things you have always cared about now are at the same time way easier to do and way more important and more valuable to do. So let's just get back to work and make them happen. Thank you so much.
I think we got time for questions.
Yes, sometime yes.
So we have got time for questions if we can get them up. Are we able to get them up, Hannah? I'll read you the one. I've got it on my phone, thankfully. Yeah? I've got them here. All right, the first question. What distinguishes teams that move beyond the 5 to 10% productivity bump into real performance gains?
So most of the times where you look at teams that say they have this kind of outlandish returns on AI, it's startups, small teams, and I think the difference is what we covered towards the end. So the less the layering that you have, we'll talk about that, yes. Yeah. The less the layering you have in your team, the more people can I don't know, individuals can ship entire features, and the more time they can spend building, the more AI is going to help you. Because I can tell you for sure, AI is not going to help negotiate with your PM on estimates or on resource allocation. AI is still not good at that, as far as I know. So that's the quick recipe.
Good, eh? All right, over to our top question. What can I do to get CEOs to stop just asking to do AI? And before you answer that, you can put your name in, and it's come as anonymous, so you are a coward for not putting your name in there.
Stand up.
Yeah.
Yes.
Does anyone want to admit to it? No, because it was me.
So is there any CEO here who is asking about AI? Yes. You can pretend that you're using AI. Make your CEO happy. Yeah.
Okay, let's go to a real question. You like that question?
No, I mean, seriously, I think even CEOs understand this is complicated. So even CEOs, yes. That's my engineering bias that doesn't consider them real work, right? And so I think using AI is a horizontal technology. It's not like, let's use this framework, right? It's something that is organizational also. And so to get the most benefits has to be something that is across your own organization. And so it takes time and it takes a lot of work. So I think the best way forward for many teams is to try to make experiments, to try to make small success stories. You might think at a team in your organization that is more eager to try this stuff, that is in a better shape, not overwhelmed by technical debt, cognitive load, and so they can do more experiments with AI and report back. And so I think case studies, small success stories in teams are a good way to satisfy those questions and to create progress.
Thank you. So we did that one. So is documentation more or less important now that we have AI?
I think it depends on what documentation, because when you think at the prescriptive, low-level documentation about how things work, tech specs and stuff, that might be a little less important in the sense that AI can create it very well. And also, honestly, AI can figure out a lot of things about the code base by itself. So there's a chance this is a little less important. But there is another kind of documentation that is way more important, I think, that is why we are doing things, what kind of decisions we made to get to this kind of decision. And so this is something that AI can't figure out just by looking at the code base. So if you're not the one that tells it, it can't figure it out by itself. And so that's a thing that is 100% human. It's on us. So there is more important and less important documentation, I think.
We've got time for probably one more, maybe two. How to make the best of MCP servers?
I think it's still very early. I think many MCP servers are a little bit clunky, are slow, and sometimes what you lose in terms of speed is not always compensated by the value you get. There is like a greatest hits of the ones that I like the most. There is Context 7, which forces AI to use the latest, most up-to-date versions of libraries and documentation, because otherwise it's easy to hallucinate. There are MCP servers for security checks and quality checks, like CodeSyn and Codacy. There are many. I think you should just experiment, because here is like, it's the real frontier where things are changing all the time. There is Playwright, which allows AI to navigate websites to test things if they're already working. It's not 100% reliable. So I think rather than just pointing to specific ones, I'm just saying, go try as many out as possible and report back to me also.
Cool. And then very, very quickly, how to fight the mediocrity of most AI output, especially on documentation?
I think that we should use everything that AI does as a draft.
Yeah.
And so nothing should, be just shipped and become official without a human looking at it and reviewing it. So that any crap that comes out of AI that happens all the time gets filtered by good humans' eyes. But even if we look at every single change, if we do things right, I think it's a net positive.
Good stuff. Well, thank you everyone to Luca. That was awesome.
Thank you. Thank you so much.